React is constantly evolving, and the team has been hard at work researching and developing new features to improve developer experience and user experience. React server components combine the benefits of server-centric and client-side rendering for efficient data fetching. The framework is also working on asset loading APIs for seamless loading of scripts, styles, fonts, and images across all React environments. Off-screen rendering, which improves performance by deprioritizing hidden content and enabling new patterns, is also pretty exciting. Transition tracing is a new profiling API that assists developers in tracking interactions and identifying performance bottlenecks more effectively. Today, I'll be diving into two of these features more deeply: React Compiler, which automatically generates memoization code to optimize re-renders, and server actions, which simplify communication between components and the server for data mutations and form handling. We'll explore how they work, what their benefits are, and how they can help you build better React apps. Let's get started. Now, as React developers, we strive to build apps that provide a great user experience. However, achieving optimal performance often comes at the cost of developer experience. You really want to write component code that's like this to-do list, that's clean and readable. But what about once performance becomes a concern? Imagine if we have to execute changes hundreds of times. We find ourselves resorting to manual memoization techniques, such as use memo, use callback, and React memo to optimize our components. Now, while these techniques work, they can make our code harder to read, understand, and maintain. Here's an example of a to-do list component that uses manual memoization. As you can see, the code is more verbose and harder to reason about. We have to wrap the to-do component with React memo, use callback for the handle change function, and use memo for filtering the to-dos based on visibility. These optimizations come at the cost of readability and maintainability. Imagine if we could write React code without worrying about manual memoization. What if we could have the best of both worlds? A great developer experience with regular JavaScript values and syntax, and a great user experience with fast, fine-grained reactive updates. This is where React Compiler comes in. React Compiler is a new build tool that automatically optimizes your React app. It works with plain JavaScript and understands the rules of React, so you don't need to rewrite any code to use it. The React team has been testing it out at Meta and is already powering a few production surfaces, like Instagram. The biggest impact the React team has seen from the compiler is preventing the cascade of unnecessary renders. React can sometimes do more work than needed when an entire subtree needs to be re-rendered, even though not much has changed in the UI. The compiler can figure out exactly what's needed to prevent cascading renders and compile fine-grained memoization versions of your code to stop that. The React team has seen that the compiler can do this even more precisely and granularly than if you'd used use memo or use callback by hand. In this example, we have the same to-do list component, but without any manual memoization. The React compiler optimizes the code by creating memoized versions of the handle change function, the filter to-dos, and the rendered JSX. It also intelligently updates the memoized values only when the relevant dependencies change. So just write in the idiomatic React code. With React Compiler, we can write idiomatic React code and let the compiler handle the optimizations for us. Auto-memoization is the main optimization that's been built so far, so other ideas like auto-dependency arrays for APIs like useEffect haven't been worked on just yet, but the team is discussing it. Auto-memoization is just the first step in the journey of optimizing your React app. The goal of React Compiler is to provide the best of both worlds, a great developer experience and a great user experience without any compromises. By automating the memoization process, React Compiler allows you to focus on building amazing apps rather than worrying about low-level optimizations. If you want to prepare for React Compiler, the React team highly recommends using strict mode and React's ESLint rules to fix issues that these tools highlight. By following the rules of React, you'll have a healthier code base, and it'll also give the compiler an easier time when it's ready. Next up are server actions. Now, server actions are a game-changing feature in React that allow you to seamlessly integrate server-side logic with your React components. They maybe missed a trick here in not calling them ReActions. Server actions provide a declarative way to handle data mutations and form submissions, making it easier to build interactive apps. With server actions, you can define server-side functions that can be invoked directly from your React components, eliminating the need for manual API calls and complex state management. Let's see server actions in action using a to-do example. First, we define our server-side function add-to-do using the useServer directive. This function receives the form data as a parameter and performs the necessary server-side mutations, such as adding the to-do to a database. In our React component, we create a form and specify the action prop with the add-to-do server action. When the form is submitted, React automatically invokes the add-to-do function on the server, passing the form data as an argument. Server actions handle the form submission and perform the server-side mutations seamlessly. Now, beyond handling actions, server actions also streamline fetching data from the server. Unlike that last example where we focused on adding to-dos, here we use server actions to fetch and display to-dos. This shift demonstrates server actions' versatility in both sending data to the server and retrieving it. By using a getToDo server action, we can directly fetch the list of to-dos from the server and render them in our React component, showcasing the power of server-side logic integration for both read and write operations. Now, while we won't be going deep into React performance, I did want to give a shout out to INP, Interaction to Next Paint. It's the new Core Web Vital metric that assesses page responsiveness, like the latency of all click, tap, and keyboard interactions within a page. Check out our guide to learn how you can use features like Start Transition to improve the responsiveness of your pages. As we've seen, React Compiler and server actions represent a significant leap forward in React development. By leveraging these powerful tools, developers can achieve optimal performance and productivity without sacrificing code quality or maintainability. React Compiler automatically optimizes our code, allowing us to focus on writing clean, idiomatic React. Server actions revolutionize server-side logic integration, enabling a declarative approach that eliminates complex boilerplate and enhances the developer experience. I encourage you to embrace these cutting-edge tools and witness their transformative power firsthand. Dive into the ReactConf talks, explore the code examples, and experience the joy of writing clean, performant, and maintainable React code. The future of web development with React is bright, and adopting React Compiler and server actions is going to help you stay at the forefront.